observe, the symbol of weight is W, so weight is equals to force, which is equals to, what is the formula everybody? Mass into gravity or gravitational force. Gravitational force. Now you tell me, Mr. Harizeras, you said your mass is 55 kg. Now, what is your weight? Can you tell me? Yes, please. You said your mass is 55 kg. What is your weight? So your weight is, suppose if I'll take 55 kg object, then if my weight is 55 kilogram into, I am falling towards the earth. If I am falling towards the earth, so my gravitational force is 10 meter per second square. So this is what it is. So now my weight is 550 kilogram meter per second square, which is equals to 550 newtons. So what is your weight? Weight, Mr. Harizeras? What is your weight? 550 newtons. That is what. Now, Mitakshri and Divya, everybody I am asking you, is it the G value is constant throughout the universe? Of course, mass is constant, I know that. Is it the G value is constant throughout the universe, Harish? Yes, please. I am asking the question. Is it the G value is constant? Is G value is constant throughout the universe? I am asking. Yes, please. What is your answer? Yes or no? I already taught you G value so many days. Is the G value is constant throughout the universe? I say yes or no, yeah. So cannot interested, you can leave from the meeting. No issues. We'll study tomorrow. No problem. Is it G value is constant throughout the universe? I am asking.
No, sir.
You say yes or no. You say means I will say correct. What is the G value of Earth? What is the G value of Earth? Average G value.
9.8.
Meter per second.
9.8, sir.
This is Earth. What is the G value of Moon? What is the G value of Moon? Everybody. Moon. 1.6 meter per second square. What is the G value of Sun? Around 372 meter per second square. Now, is it the same throughout the universe?
No, sir.
No. Now,
No.
as I taught you, G value varies on the Earth itself because Earth is not a perfect spherical. So, where it is having larger radius? At equator, at poles. Earth, if you consider.
Equator.
At equator, it is having larger radius compared to at poles because at poles, Earth is having a flattened surface. So, factors affecting G. Do you remember everybody? Factors affecting G. Yes, Mitakshri?
Yes, sir.
Yes. So, here radius of the Earth is less. So, G value is little maximum more. And here radius is maximum. So, G value will be what? Minimum. So that is why I told you, the gold which you purchased in Jammu Kashmir having different weight, the gold which is purchased in Tamil Nadu will be having different weight. The same gold, if you take it into Jammu Kashmir, you cannot sell there because the weight is different. The same gold if you bring there, if you go to America, you cannot sell because they are different weight. Because why? G value is not constant. Understand everybody? So now you tell me, is the G value is constant across the universe or not? That is what my question. If the G value is not constant, then weight of the body is constant or not? That is what my question. Hariseras, Arun Kailash, everybody. Gokul, answer my question. If G value is not constant, you are saying, of course, is it G constant throughout the universe? Not throughout the universe. If you are standing in Pudukkottai, if you go to the Kumbakonam, G value will be having slight variation. Understand, Mr. Harish, Kaushik? If you go to the Chennai, there also small variation. If you go to the Jammu Kashmir, variation. If you go to the West Bengal, variation. If you go to the Gujarat, variation. If you go to the Kanyakumari, variation. But on the earth, approximately it is equals to what? Approximately it is equals to what? Everywhere it will be equals to 9.8 meter per second square. But it will be varies. So if you'll go to the suppose, if you'll go to that equator, you will get 9.62 like that. If you'll go to the poles, 9.77 maximum. If you go to the this side, maybe 9.72. If you go to here, 9.71. Like that, small variation. But rounding off, what we are taking? What is the gravitational force of Earth? Rounding off towards to the Earth, entire Earth. How much? 9.8 meter per second square. See, on the Earth itself, gravity is not constant. So, weight is also not constant. Then, what about the universe? If you go to the moon, if you go to the sun, if you go to Mars, if you go to Neptune, is it G value is constant? G value is not constant. So, if G value is not constant, no, then is it weight of the body is constant? That is what my question. Yes, everybody. Mr. Harish. Yes.
No,
Is
sir.
weight of the body is constant? Can you understand what I am saying, Harish?
Yes, sir.
Yeah. So that is what you should tell me. So what we can do now? So what is the point we can say? Weight of the body remains constant or not constant? What is answer? What is your answer? Gokul Krishna? Arun Kailash? What is your answer, Mitakshri? Weight of the
Not constant.
yeah.
It is
Weight
not
of
constant.
the body. Weight of the body is not constant. Not constant from place to place. Place to place. Because what is the reason? Because G value is not constant. Is it okay, guys? Everybody, please respond.
Yes, sir.
Yes, that is what it is. Now, I taught you, can you tell me what is the relationship between gravitational force of Earth and gravitational force of Moon? Anybody can tell me? Gravitational force
So,
of Earth and gravitational force of Moon. I taught you this. Gravitational force of Earth is 6 times gravitational force of Moon, or else gravitational force of Moon is 1/6 times of gravitational force of Earth. Is it yes, Harish Jairas? Do you remember this? Mitakshri?
Yes, sir.
Yes. For example, if Harish Jairas is weighing, weight of Harish Jairas on Earth is 550 Newton. Now the same person will go to Moon. What is his weight? Anybody can tell me? Yes, please. What is his weight? He will be around 91.6 Newtons. Is it right or wrong, Hari? Yes, Mitakshri? Divided by
Yes,
6.
sir.
Yes or no? Because his weight of Moon is almost, see, because gravitational force is 6 times is decreasing. So weight is also decreases by how many times? How many times?
16.
6 times. So I can say weight in Moon is equals to 1/6 times of weight in Earth. So please remember this, because as it is Earth, Moon is the natural satellite for the Earth. Always will study about Earth and Moon. That is what I am saying. As it is, gravity is decreasing 6 times. Understanding, gravitational force of Earth is 9.8 meter per second square. If you do 9.8 divided by 6, which is equals to how much amount? If it equals to gravitational force of Moon, which is equals to 1.63 meter per second square. So 6 times of DC, multiply with the 6, you'll get 9.8. So gravitational force of Earth is 6 times more than the gravitational force of Moon. So weight on Earth is also 6 times greater than, weight on Earth is also 6 times greater than weight on Moon. Is it yes? Mr. Harish Jairas, Purima Purilla. Understand? Johan? Clear? So, I can say weight of the body is not constant from place to place. It is depending on the direction and as well as magnitude. So, it is a vector quantity or scalar quantity? Yes, please. Weight is a vector quantity because it will depends on depends on magnitude and as well as what? Magnitude and as well as everybody. As well as whom, guys? As well as direction. So, if say Mitakshri, as I said in the case of mass, if she will move east, if she will move west, if she will move north, if she will move south, her mass is always constant. But who is not constant? W is not constant because G is not constant. Understanding, everybody? G is not constant. Understand, Mitakshri now? Gokul, everybody?
Yes, sir.
That is what. So be very.
Yes, sir.
So place to place it will vary. Even on the earth itself it will vary. What about universe? Everywhere it will vary. Understand, Harijeras, as it earth and moon always is a matter for us. So we always will learn the relation. If gravitational force becomes 6 times less, then weight also becomes 6 times less in moon. Is it okay? Now, can you tell me what is the SI unit of weight? SI unit of weight. By this time you will understand. SI unit of weight. Yes, please.
Newton, sir.
Newton. What is the SI unit of weight? Newton. Same like force. Remember, symbol is N. So, and we also remember 1 Newton is equals to 1 kilogram meter per second square. Is it okay, Kaushik? Kaushik? Okay. Next.
Yes, sir.
CGS unit of weight is dyne. What, Hari? Dyne.
Nine.
You can take even kilogram force. Even dyne also don't remember. Remember KGF, not Kolar Goldface, Movira. KGF means kilogram force. What is that? Kilogram force. Okay, Mitakshri? Kilogram force. Understand that? That is what it is. Okay? But actually, I'm also doing small error. Remember, it's not the CGS unit. Please rectify. It is also the SI unit only. Gram force is the CGS unit of weight. KGF is the SI unit, Newton like. Newton and KGF are both are SI unit only. Now CGS unit of this one, you can take it as a dyne or you can take it as a gram force. What is that, Hari? This is kilogram force, this is kilogram force and this is gram force. Again I'm saying, remember 1 kilogram force is equals to 1000 gram force. Okay, same way 1 kgf is equals to 10 newtons. Understand, everybody? Harish, Mitakshri, for numericals it is very important. Same way 1 kg is equals to 1 kgf. So, which is equals to 1 kg is equals to also 10 newtons. For numericals, it is very, very important. 1 kgf is equals to 1 newton. Sorry, 1 kgf, 1 kg. So 1 kg is equals to 10 newtons. Understand, Hari? Understand, Mitakshri?
Yes, sir.
Yeah. So now,
Yes, sir.
why means I will say you, sir, why 1 kg is equals to 10 newtons means, let me imagine now, let me take Harini is standing now. Harini is, this is Harini hand. Harini is weighing 1 kg mass. What is the mass, Mitakshri? Harini is weighing 1 kg mass. In where? Where she is weighing? In her palm. Understanding? So she is carrying 1 kg mass in her hand, in palm. Then the force of attraction acting on the ground, how much it will acting? At what force it will pull down? It will pull down at what force? 1 kg mass. What force it will pull? 10 meter per second. Understanding? So with this force, Earth is trying to pull this 1 kg mass. So if 1 kg mass, if I am carrying in my hand, then how much weight it will acting? What is the force it is acting on my hand? What force it will acting on my hand? 1 into 10, which is equals to 10 newtons. That is why I will say 1 kg is equals to 10 newtons. Understand, Mitakshri? So if I'm carrying 1 kg for 1 kg body in my hand, then 10 Newton force is acting in my hand. That is what you have to remember. Is it okay, Hariseras? Yes. So that is what 1 kgf is equals to 10 newtons. Same way, 1 kg is equals to 1 kgf. So 1 kg is equals to 10 newtons. So this is what SI unit of weight, Newton, and Cgs unit is gram force. Okay. Now also I will teach you for your purpose dyne also, force unit. The Cgs unit of force is dynes. Cgs unit is dynes. 1 Newton is equals to 10 power 5 dynes, means 1 lakh dynes. All of you should remember. 1 lakh dynes is equals to 1 Newton. Okay, Mitakshri? Numericals, it is very, very important. We'll get the numericals lot of. So this is what about it. So now, last point of today's class, I don't want to waste much time. You can leave. Now you tell me, is it weight will become, as if you know that weight will never be constant throughout the universe. Now my question is it possible to make the weight of the body zero? Somewhere it will become. Yes, anybody can guess? Is
The
it
center of
possible
it.
to make the zero? Is W become zero? W becomes zero at where? Becomes zero. Then when and where? Everybody?
Sir, center of it, sir.
Very good. Because yes, mass never be zero. Mass never be zero. Everywhere constant, and it is same. Now W always varies. W always varies. At it will become zero at particular place at center of the earth. Center of the earth, not only center of the earth. If I'll go to the center of the moon, if I'll go to the center of the sun, if I'll go to the center of the Mars, everywhere at the center, what is the G value? That is what my question. At the center, G value is what? Everybody,
0.
what is G value at center? G value is 0 meter per second square. Now, if Mitakshri will go to the center of the earth, she went to center of the earth. Center of the earth we can represent with the CRO, your choice. Now, her weight is equals to 55 kg into, what is the G value at the center? 0 meter per second square. So anything into 0, 0 only. So 0 kilogram meter per second square. So 0 newtons. So her weight at the center, if you go any planet, center of the planet, the G value, weight of the body is 0. So weight can become 0 in some cases. Exactly where, guys? When you go to where? Center of the earth. When you go to center of the earth, your weight will become 0. That is what you have to remember. So please write that point and we'll stop it. So SI unit is Newton. SI unit is Newton. SI unit is Newton. Or what is another SI unit? What is another SI unit? KGF. Kilogram force. Okay, Hari? Or we can say kgWTT, kilogram weight. Understand, Hari? kgWTT, or we can say kgf. Both are same. Kilogram weight or kilogram force. Both are same only, guys. Remember. kgWTT. What do you mean by kgWTT, Mitakshri? Divya? Kilogram weight. Okay? Or kilogram force. Which is equals to what? How many newtons? 1 kgf equals to how many newtons?
10
How many
Newton.
newtons? 10 newtons. Or exactly if you want, how many newtons? This is rounding up.
9.8 Newton.
9.8. That is also you have to remember. Understand, Ra? Arun Kailas will never say anything. Yes, sir. No, sir. Gokul, Mitakshri. That is what.
Yes, sir.
So this is what is weight and what is
Yes, sir.
mass. So weight of a body will become 0 or not? Where weight of a body will become 0? Weight of a body will become
At
0 at center of the earth. Because at the center of the earth, who is 0? At the center of the earth, who is 0? G value is 0. So that is why weight will become 0. So till here you study. I'll send the PDF also, you can write. So thank you everybody. We'll meet tomorrow. We'll study the next concept is called as I told you. What is the next concept? Center of gravity. Okay. Thank you everybody. Bye.
Thank you, sir. Bye, sir.